Then we said E is equal to minus dV by dr. If I want to move in this direction, this is delta V, this is delta R. Here and here I will find out potential. Potential difference divided by distance, I will get the field in that respective direction. Right? Now consider delta V is minus integral E dot dr. Right? dr brought to the left, we integrated. You want potential at a particular point at a distance of r. Minus V infinity is minus integral E dot dr from infinity to small r, or from R1 to R2. Then this will be R2 minus potential at R1. Then we said for an infinite long wire at a distance of r, the field is 2k lambda by r. For a semi-infinite wire, the field will be k lambda by r and k lambda by r. Semi-circular wire, the field will be 2k lambda by r. This is what we have done till now in gravitation. Yes or no? Did we deal with this for a ring? Field due to a ring. Pardon?
Yes.
Semicircular wire. That's all?
Yes.
Ring.
We have done.
GMX upon
For a ring? If I have done for a ring, if this is x and this is a, potential is minus gm upon under root a square plus x square. Field will be gmx upon a square plus x square to the power 3 by 2. It's a must that you remember this result by heart. Right? Potential minus gm under root a square plus x square. Field gmx upon a square plus x square to the power 3 by 2. Field will be maximum at a distance of a by root 2. A by root. I took the magnitude on both sides. How do I get this? Differentiate field with respect to distance and equate it to 0. You will get x is equal to plus or minus a by root 2. Till here, is everybody clear about what we have done? All of you? Can we proceed?
Yes.
Next class, each section, say I'll ask 1 or 2 students the formulae for field and potential for all the bodies that we derive. You should have it on the tip of your tongue. Clear? Did we solve this problem of this is a ring and this is an infinite long wire? The ring is of radius A, mass capital M. Lambda is the mass per unit length of this semi-infinite wire. This wire is semi-infinite. It starts from here, goes up to infinity. They are asking you force on the semi-infinite wire due to the ring. Will you try or should I discuss? Louder. Wonderful. Field into mass will be the force. Now field is varying. Obviously calculus will come into the picture.
So is the answer GM minus GM lambda by A?
Lambda by A. I think no. Wait, though I don't remember the answer, I think this is no.
So G lambda by 2A.
Tane, I think the first guy's answer is right. GM lambda by A. GM lambda by A may be right. There are 2 ways of looking at it. Have a look at it. Traditionally, if I were to solve this problem, because I asked you force on the semi-infinite wire due to the ring, due to the ring at a distance of x, what will be the field? Field will be gmx upon a square plus x square to the power 3 by 2. df will be field into dm, field into mass. Field is g capital Mx upon a square plus x square to the power 3 by 2 into lambda dx. At a distance of x, you consider an element of length dx. This is force on the small element. Integrate this from 0 to infinity, you will get the answer. This is one way. Standard substitution for this will be x is equal to a tan theta. Or two alternatives, two ways of doing this. Either put x is equal to a tan theta, dx is equal to a secant square theta d theta. Other way of doing this is, whenever I have got x dx in the numerator, put t square is equal to a square plus x square. 2t dt is equal to 2x dx. 2t dt is equal to 2x dx. Right? Fine. Now, these are the two ways of dealing with this. What is the other procedure that we have got? Newton's third law. Every action is an equal and opposite reaction. Force due to ring on the wire you calculated. Force due to wire on the ring also you can calculate. So, because of the wire, here I will have one field, here I will have one field. K lambda by A, and this will be K lambda by A. Semi-infinite wire. Now this K lambda by A will produce a force which will be radially inverse on every element. This K lambda by A will produce a force which is radially inverse for every element. That will cancel out. Right? This will be left over. dF will be K lambda by A into dm. Integral of this, why did you bring this out? This is a constant. Integral of this is K lambda capital M by A. This is force due to the wire on the ring. Force due to the wire on the ring. Both should be the same. You can integrate and see, you will get the same answer. Make it fast. These results are very important, also termed as shell theorem in Halliday-Resnick crane. We will exploit this to the fullest extent in electrostatics. Then we will derive using Gauss law. Now we will derive using the traditional calculus. Right? Once we deal with this using Gauss law, you will be able to solve it in 2 steps. Then why don't you teach that now? Then you will never learn this traditional procedure. Hence traditionally we solve it right now. I want the potential and field at an external point for this hollow sphere. This is a hollow sphere of mass m and radius r. I want the potential and field at an external point. Let us consider this distance to be r from O. Consider an elemental ring. Consider an elemental ring. This is r d theta. Consider an elemental ring. Thickness of that ring is r d theta. What will be the radius of the ring? R sin theta. What will this distance be? R cos theta. What will this distance be? R minus r cos theta. Are we all okay with this? We considered an elemental ring. Radius of the ring will be r sin theta. Distance of the center of the ring from here will be r minus r cos theta. For a ring, what did you tell me was the formula for potential? If this is x and this is a, this is under root a square plus x square. Potential you told me is minus gm by under root a square plus x square. Agreed? Now, this distance will be, I will call it z. That is our under root a square plus x square. Distance from the top of the ring to this point. So technically your potential is minus g dm by z. dm is the mass of the ring. Either I should bring dm in terms of z or z in terms of dm and integrate. Right? Firstly, let me substitute for dm. Mass per unit surface area, hollow sphere, into surface area of the ring. How do I get the surface area of the ring? Cut it and make it straight. It will be 2 pi r sin theta into r d theta upon z. Mass per unit area into surface area of the ring. Surface area of the ring 2 pi r sin theta into r d theta. Agreed? This z I kept it as it is. 2 pi will become r square will go minus gm by 2z sin theta d theta. Now bring z in terms of theta or theta in terms of z and you get the answer. Integrate it, for which see what we do. Z square is equal to r square sin square theta plus r minus r cos theta whole square. What did I use? Pythagoras theorem. R square plus r square minus 2 small r capital R cos theta. Agreed? Z square. 2z dz by d theta will be 0 plus 0 minus 2 capital R small r minus of sin theta. Z dz upon small r capital R is sin theta d theta. Agreed? So now I have a substitution for sin theta d theta. Now I have a substitution for sin theta d theta. So potential will be equal to minus gm by 2z z dz upon r capital. Z dz upon r capital. I have z right, 2z sin theta d theta.
Z will cancel.
Wait, I have committed a mistake here. This will be dv is minus gm by 2z. Am I right? Or did I commit a mistake?
No, sir, you are
Z dz upon small z will cancel. Okay, I forgot to cancel this. Gm by 2 small r capital R. Integral dz will be z. Integral dz will be z. Here integration is not difficult. Now watch out for this. See the limits of this carefully. You need to concentrate for the limits. Least value of z. The ring that you consider is from here till here. When I consider the ring here, the value of z is small r minus capital R. Yes or no? When I consider the ring to the extreme right, the distance of z will be small r minus capital R. This distance will be small r minus capital R. When I consider the ring at the farthest extreme, the distance will be small r plus capital R. V is equal to minus gm by 2 small r capital R, r plus r minus r plus capital R. Minus gm by small r. This sounds familiar to me. If whole of the mass appears to be concentrated at the center, the potential would have been that. Are you trying to tell me that for any external point, whole of the mass appears to be concentrated at the center? Yes. For any external point, whole of the mass appears to be concentrated at center. Right? In that case, what will be the field? Gm by r square. I can get this by two ways. One, using the result that I just told you. For any external point, whole of the mass appears to be concentrated at the center. Second, differentiate this, you will get that answer. D by dr of this, you will get this. So for any external point, remember this result, it is very important. For any external point, whole of the mass appears to concentrate at the center only for a sphere. A cuboidal box, no. Only for a sphere, for any external point, whole of the mass appears to concentrate at quick. If I rub the board, how many of you can do the derivation?
Yeah, we can try.
You will be more amused to see when I deal with this for inside the sphere. Now listen, if I select a point inside the sphere, for a point inside the sphere, watch out for this. You have taken an element here. I have selected the point here. Now the ring that I consider is from here till here. Am I right? What will this distance be? This will be capital R minus small r, because small r is the distance from the center. What was the integral for you? dv is minus gm by 2 small r capital R integral dz, right? Now what will be the limits of dz? Distance of this point from the ring here will be capital R minus small r. Distance of this point from the ring on the other extreme will be capital R plus small r. That becomes minus gm by 2 small r capital R, r plus r minus r plus small r, minus gm by capital R. Are you trying to tell me anywhere inside the potential will be the same as that on the surface? Yes. Are you trying to tell me potential inside the hollow sphere will be constant? Yes. The field by default will become 0. Why will the field become 0? dV by dr. That means if I take a point mass from here till here, till here, till here and move it inside a hollow sphere, what will be the work done? 0, because delta V is 0. Right? Hence, field inside a hollow sphere will be 0. Field inside a hollow sphere will be 0. This is shell theorem. Rather the most important in electrostatics with the concept of shielding. Remember this result. Suppose I deal with a solid sphere. For an external point, have a look at it. I'll consider an elemental shell. I'll consider an elemental shell at a distance of x of thickness dx. This is r, distance from O. Radius of the sphere is capital R. I want the potential here. What will be the potential? Because of the thin shell, for an external point, it will be minus g dm by small r. For any external point, whole of the shell appears to be concentrated at the center. This is what we have learnt. For any external point, whole of the shell appears to be concentrated at the center. Right? Now, minus g dm by r. How did you do this integration this way? Integral dm will be total mass of the shell. R is a constant because for every shell distance from the center, concentric shells will be the same. Minus gm by r. Expression for potential implies even for a solid sphere, for any external point, whole of the mass appears to be concentrated at center. Right? Even for a solid sphere, for any external point, whole of the mass appears to be concentrated at center.
Is there any physical reason for that?
Field gm by r square. Field gm by r square. What if you are dealing with potential and field inside the solid sphere? Inside the solid sphere. Firstly, let me deal with the field. Consider I want the field at a distance of small r. I want the field at a distance of small r. You will take this to be m1 and this to be m2. The mass inside the radius of small r is m1. Mass outside the radius of small r but within capital R is m2. Right? Net total capital M is m1 plus m2, quite obviously. Now field here at a distance of small r is field because of m1 plus field because of m2. Agreed? Field because of m2 will become 0. Why? I can consider thin spherical shells in m2. Each of the shell will give me 0 field inside. If I add all the zeros from small r to capital R, obviously it will be a 0. I repeat, m2 I can consider to be constituting thin spherical shells. Each shell will give me a 0 field inside. Sum of all the zeros will give me a 0 here. All I will have to do is calculate field because of m1 on its surface. Field because of m1 on its surface. This will be minus G m1 by r on its surface minus G m1 by r square, sorry. Right? Minus G mass per unit volume 4 by 3 pi r cube. 4 by 3 pi r cube into 4 by 3 pi small r cube. This is m1 by r square. Field is y minus field I am calculating G m r cube by r into r. R square r cube I am left with r, denominator capital R cube. That means if I draw a graph for field versus distance from center, it will be a straight line till I come to the surface. Outside the surface, it will be 1 by r square. Directly proportional to r, inversely proportional to r square once it crosses the surface. So field for a solid sphere inside the solid sphere is directly proportional to distance. Right? Field for a solid sphere inside the solid sphere is directly proportional to the distance. Once you cross the radius, it will be inversely proportional to r square. Quite a few times we would prefer to use this formula in terms of density. We will write field as G, density into volume, 4 by 3 pi capital R cube upon R cube into R. D is density. Field will become 4 by 3 pi dg small r. Quite a few times we would prefer to use this formula in terms of density and not mass. Now potential inside a solid sphere, small r, this is m1 and this is m2. Potential is potential because of m1 plus potential because of m2. Yes or no? Potential inside a solid sphere. Potential inside a solid sphere. If I want the potential at a distance of small r from the center, the mass which comes inside this radius is m1, but mass which is outside this radius is m2. Fine. I will have to calculate because of both. Because of m1, Vm1 will be minus G m1 by small r. For a point on the surface, whole of this mass will appear to be at the center. For a point on the surface, whole of m1 will appear to be at the center. This is minus G mass per unit volume 4 by 3 pi r cube into 4 by 3 pi small r cube upon r. This will turn out to be minus gm r square by r cube. This will be potential because of M1. Is it clear to all? Now I will have to calculate potential because of M2 inside. This is a bit subtle. Observe this carefully. Potential because of M2. Potential because of M2. Have a look at this. You will consider a thin spherical shell. If this shell is at a distance of x and the thickness is dx, whatever is the potential due to this shell on its surface, everywhere inside it will be the same. Potential due to the shell dVm2 will be minus g dm by x. This will be the potential due to the shell on its surface. Everywhere inside it will be the same. So here also it will be the same. This will be minus g mass per unit volume 4 by 3 pi r cube into volume of the shell 4 pi x square dx upon x. You have considered M2 to constitute of a thin spherical shell. If this shell produces this potential on its surface, everywhere inside it will produce the same. Mass per unit volume into volume of the shell 4 pi will go minus 3 gm by r cube integral x dx. Least value of x is small r, maximum value of x is capital R. Vm2 is minus 3 gm by r cube. This will be 2 because x square by 2, r square minus r square. Add up both of them, V will be equal to minus gm r square by r cube minus 3 gm by 2 r cube r square minus r square. If you take LCM, it will be minus gm by 2 r cube into 3 r square minus r square. JEE people played with the students here. They gave a question on this. See, we will never tell you people to remember the formula F equal to MA. Did we ask you to memorize that? But you will remember that formula. Why? You have used that n number of times. The more the number of times you use a formula, you will remember it by default. It is not whether it is complicated or easy. Right? Now, potential, in 90% of the problems, you will use potential and field outside the sphere. Solid sphere ka andar ka potential, you will solve 1 or 2 problems on it. So by default, student tends to forget this formula. Now JEE people gave one question for 2 marks on this formula. Now everybody knew that they had to conserve energy here and here. Those steps mein ho jayega. It's worth 2 marks provided you remember this expression. Now students who remembered this expression could solve it. Students who couldn't remember this expression, despite the fact they knew how to solve the problem, could not solve it. Reason? For 2 marks I cannot sit and derive this. You are given only 2 marks for that question. You cannot sit and derive whole of this, right? So you will leave it by default. Undoubtedly JEE is a concept based paper, but at least one question in the paper will be based on such formulae. This was exploited once. So keep a track of all the formulae the day before you are going to the examination. In our crash course booklets before every chapter we have summarized this formulae, which you will receive after the syllabus is over. Before going to the examination, see the formulae once. One question with 2 marks, for me it makes a difference. It will turn tables upside down. Right? Take it down. We will summarize the results of hollow sphere and solid sphere once. Somebody got disconnected.
Sir?
Yeah?
So we derived the formula for E, so why don't we write it as minus dV by dx and integrate it?
You can. Have a look at it. This boy's doubt is, all of you concentrate here. Delta V is minus integral E dot dr. Please pay attention here. you need to understand one point. I have a problem here. The field inside the sphere is different when compared to field outside the sphere. And potential is defined as the work done in moving a unit mass from infinity to this point. Potential is defined as the work done in moving. Which center is that? AKOLA, the other center, are you people back? Which was disconnected a few seconds back. Yes, sir. Wonderful. Okay, listen. Here the boy's doubt is, can I use, you define the field for the solid sphere inside. Can I use this formula to get the answer? Instead of taking M1 and M2, you can comfortably get the answer, provided field inside the sphere and outside the sphere are different. And potential ke liye what did you define? Work done in moving a unit mass from infinity to this point. For the solid sphere, infinity to capital R I have a different expression for field. Capital R to small r I have a different expression for field. So you write this as integral E dot dr infinity to capital R minus integral E dot dr capital R to small r. Then I will get delta V, V small r and V minus infinity. V at small r minus V at infinity will be 0. Here, what will be this field? From infinity to capital R will be Gm by Gm small r by r cube. From capital R to small r, sorry, this is Gm by r square, and this will be Gm small r by r.
Capital R square.
No, outside.
Smaller.
Outside at a distance of small r is a variable from infinity to capital R. Now when you solve this, listen carefully, when you solve this, you will get the same answer without the negative sign. You can solve this and see, you will get the same answer without the negative sign. dr is negative. I am coming from infinity to small r. That means small r is decreasing. If small r is decreasing, dr must be negative. If I don't take negative, on solving this, solve and see, you will get the same expression without the negative sign. Why? Because dr is negative, r is decreasing. You are coming from infinity to small r is decreasing, dr should be negative. Let me summarize the result. What we do after this will be very important. Do this integration at home. You will get the answer without the negative sign. Make a note of it that dr should be negative. Hollow sphere for an external point, whole of the mass appears to be concentrated at the center. Potential will be minus Gm by small r. Field is Gm by r square. Agreed? On the surface, potential is minus Gm by capital R. Field is Gm by r square. So you are replacing small r with capital R because you are coming from external to on the surface. Inside, potential minus Gm by capital R. Field is 0. Inside, potential minus Gm by capital R. Whatever is the potential on the surface, everywhere inside potential should be the same. As the potential is constant, field will become 0. This was the result for hollow sphere. Right? Solid sphere for an external point, potential is minus Gm by small r. Field is Gm by r square. For any external point of the solid sphere, core of the mass appears to be concentrated at center. On the surface, potential minus Gm by capital R, field Gm by r square. Whole of the mass appears to be at the center for this external point on the surface. Inside, field Gm small r by r cube. Potential minus Gm by 2r cube, 3r square minus r square. every formula on the board, it is a must that you remember it. If I wake you up in sleep and ask you the potential inside a solid sphere, spontaneously you should give me the answer and then you should ask me who is this. Is that clear? To such an extent you are supposed to remember this. In days to come I will show you where JEE people exploited this formulae. You will not have time to derive this formula in the examination hall. They will give you this for 2 marks and 3 marks. Each of the formula you try to derive, you are screwing up your time. Right? Remember this formula by heart. Summarize this, take this down. Write it more than once so that you remember it. Generally, you people will remember these two formulae. For any external point, whole of the mass will be at the center. Because for Earth, we will use it a number of times. Inside ka formula, you will tend to forget. This is the most crucial point. Put a star there. See this more than once. Remember it. Next class, I'll ask you people the formulae. Keeping your notes closed. Right? People who don't answer it will take 10 dips continuously.
Field should also be
Yeah.
0. No?
Every batch there will be at least one student who will ask me this. Listen to the doubt carefully, this is important. The boy's doubt is, potential is constant on the surface. Then field, potential is constant on the surface. Then field should be 0. What he says is right. But then, directions do matter. Potential here and here are the same. So the field in this direction is 0. I don't mind. Potential here and here are the same. So the field in this direction will be 0. But potential here and here are not the same. Field in this direction will not be 0. Field ke liye, I will travel in this direction. Potential difference across these 2 points divided by distance. Now he is telling me on the surface potential is constant. So along the tangential direction field is 0.
Okay, sir.
You don't have a problem with that. What I have given you as the field here is along radial direction. Clear with that?
At both places we will, to find E, we will do dV by dr.
And then you will substitute small r is capital R. Displacement is 2t minus 1. If I want velocity at 2 seconds, do you want me to substitute 2 seconds here first and then differentiate it? It will become 0. I will first differentiate ds by dt. Right? Say 2t square I have taken. Now this will be 4t. I will put t equal to 2 seconds, I will get the velocity. So I will first take this as variable small r, differentiate that, find the field, then instead of small r I will substitute capital R. Somebody switch on the mic.
So, can you again repeat the thing about the tangential and radial component?
Potential, see here and here on the surface, potential is the same. So field along the tangential direction will be 0 because potential is constant. Along the radial direction field is not 0 because potential will vary along the radial direction, just inside and just outside.
Okay, sir, understood.
Back to work with this problem of SHM given by HCV. Before that, when you deal with Earth, on the surface of Earth, I want the force experienced by this mass. You are counting your money now, sitting inside. Listen, small m is kept on capital M. Capital M is the mass of Earth. What is the force experienced by small m? Small m into E. E will be the field due to Earth on its surface. What will be the field due to a solid sphere on its surface? G capital M by R square. Generally I should equate it to M into A. But then acceleration due to gravity on the surface of Earth is given a new name, small g. Acceleration due to gravity is given the symbol small g, m into gm by r square. Small g is gm by r square. We will use this formula extensively. Clear? Now, if I have small m here and this is the radius of Earth, what will be the potential energy of small m on the surface of Earth? This will be potential into mass. Potential due to capital M on the surface. This will be minus G capital M by capital R into small m. Then why did you cheat us while dealing with mechanics? You told us mgh was the potential energy then. Right? Have a look at this. If I take this to a height of h, what will be the potential energy? Potential into mass minus gm by r plus h into small m. Small r is the distance of this point from here. This will be r plus h into small m. Right? Agreed? Difference u final minus u initial minus gmm 1 by r plus h minus 1 by r. Right? Now this will be minus gmm r into r plus h, r minus h. Now watch out for this. G into capital M will be small g into r square. I substitute that small g into r square. This negative and this negative will become positive. I will keep m denominator h r into r plus h. Do you mean to say this is the correct potential energy difference between 2 points? You are absolutely right. But yet you have been cheating us in mechanics. You told us mgh. Because in mechanics I have dealt with heights which are correspondingly, if h is much smaller than r, you dealt with how much height? 1 meter, 2 meter, 10 meters, 15 meters, 100 meters. Radius of Earth is 6,400 kilometers. So this will come in the third decimal point. I can neglect the third decimal point because always my answers are up to first decimal point. So denominator is r square. I will get delta U is equal to mgh. Now recollect the statement that I told you, absolute potential is never defined. What is defined always is potential difference. When I told you mgh, I would have taken this as reference. Why? Because I told you the potential difference between these two heights. I told you you can take height h as a ground, height h from the ground surface. You can take the reference line of potential here 0, on the table 0, on the 5th floor 0. Why? Because what you are actually calculating in mgh is potential difference. Clear with that? Wait. You dig a tunnel from the north pole of Earth to the south pole of Earth. Tunnel through the center. Tunnel through the center of Earth. Drop a body from here, small m. When small m comes here to a distance of small r, what will be the force on it? Force is m into E. Agreed? What is the field inside? G, capital M, small r by r cube. This is m into A, mass into acceleration. Right? So, acceleration is gm by r cube into r. You are aware of the fact small g is gm by r square. We derived this. A is equal to gr square by r cube. A is equal to minus of g by r into small r. Why did you put a negative sign? A and r in opposite directions. R is upwards, A is downwards. Omega will be under root. Time period will be 2 pi under root r by g. 84.6 minutes. Beauty in it is, if the tunnel doesn't pass through the center, let me consider this to be smaller. There is a mass released here. It will perform oscillation. Somewhere here, let me consider this to be the force ME. Acceleration may, SHM may, acceleration is directly proportional to the negative of the displacement. Displacement should be the displacement from the mean position. right? So here acceleration should be directly proportional to x, not smaller, because that is the mean position, right? Restoring force is me sin theta. Restoring force cannot be this way, it should be to the equilibrium position. Me sin theta, m into a is m. What will be the field on this particle? It will depend on the distance from the center. So it will be G capital M by R cube into this particular distance. How do I get this distance? X by sin theta. This particular distance is x by sin theta into sin theta. Obviously with a negative sign, omega is under root g by r. Time period is 2 pi under root r by g. Right? Quick. Now listen. What HCV did to this problem is, he projected this body with a velocity of under root gr. He projected the body with a velocity of under root gr. Look at the beauty in this problem. And he didn't give you this question in gravitation. He gave you in SHM. First point I understand it is not an SHM. I projected with a velocity of under root gr. Then don't you think from here it will come out? The moment it comes out, it is not an SHM. But you gave this in the chapter SHM. He didn't give you this in gravitation. He gave you this in SHM. He wants you to forcibly convert this problem into an SHM. Because he gave it in the chapter SHM. Right? And then he is asking you for the time it takes to come from here till here. You would have calculated the field, you would have calculated the force, put force as v dv by dx, integrate from here till here, you will get the time. Pretty bad simplification, but you will get. Now how do I convert it into an SHM? Consider a hypothetical planet of radius x but the same density d, such that when I drop a body here, it will come to the other side and go back and it will perform SHM, such that when I drop a body from here, when it comes to this point, its velocity should be under root gr, so that I don't change my problem. I can give a velocity of gr under root gr in more than one way. Instead of standing on earth and pushing it, I will create a hypothetical planet of the same density, drop the body from here, so that when it comes here, its velocity will be under root gr. Now that you have created the planet, you have to give me certain statistical information. Two very important factors I need. If I would have dropped a body on the surface of earth, omega would have been under root g by r. But on the surface of the hypothetical planet, omega would be g dash by x. G dash will be acceleration due to gravity on the surface of the new planet. Right? Do I have a relation between them? First point. Incidentally, both of them will be the same. How can you say that? I will solve that using both SHM and gravitation. In SHM, did I ever tell you, pull this mass by a distance of 0.1 meter and release, it will have one time period. Pull it by 0.4 meters and release, it will have a different time period. Did we ever say that? Time period was independent of amplitude. So now when I drop a body here and it performs SHM, or I drop a body here and it performs SHM, time period should be the same. Are you trying to tell me these both will be the same? Yes. Agreed. Using SHM you are telling me, your intuitiveness will tell us that both omegas are the same. Using gravitation, have a look at it. G is 4 by 3 pi dgr. This is what you derived for field. Field is nothing but G. M into G is the force, M into E is the force. What did you tell me small g was? Or small e. This is Gm by r square. This is G density into volume. 4 by 3 pi r cube upon r square. This is 4 by 3 pi d gr. Now g dash 4 by 3 pi d gx. G by r will be equal to g dash by x. Yes or no? So this omega or this omega will be the same. You are trying to tell me you have created a hypothetical planet with the same density but with a radius of x such that I drop a body here, it will come till here and go back in 84.6 minutes. Yes. Time period will be the same. Fine. Now come to the second state. Fine. You created a hypothetical planet such that you drop the body here. When it comes here, it will acquire this velocity. Kindly tell me the radius of that hypothetical planet. Radius of that hypothetical planet. V is omega under root a square minus y square. What is v under root gr? This is the velocity it should acquire. Omega is under root g by r. Technically I should put g dash by x. I don't mind, both are the same. What is the amplitude? X square. What is the value of y? R square. Amplitude x. Value of y. Y is the distance of this point from the equilibrium. It is r. Simplify this, x will be r root 2. X will be r root 2. Hence, you have given me all the informations I need about your hypothetical planet with the same density. I have not changed the problem. How did you not change the problem? I drop the body here. By the time it comes here, it will have the same velocity. Same density for the planet. The planet should be of radius x. Now,
Sir, if I was to move the velocity of gr in the same direction, under root g by gr, in the same direction, it would be.
let me explain this. Listen, now that you dropped the body, your requirement is time taken by the particle to come from here till here. Time taken by the particle to come from here till here. That's the question asked. Convert this into a phasor. Your job will be done in one step. Do you recollect phasors taught in the first lecture of SHM? Right? Foot of the perpendicular is performing SHM. The particle starts its journey from here and it is going in anti-clockwise direction. Foot of the perpendicular is going down. That means the phasor is here. If it were here, the foot of the perpendicular would be going up. The foot of the perpendicular is going down. That means the phasor is here. This distance is r root 2. This is r. What will this angle be? Then what will this angle be? 100. You are asking me the time taken by the foot of the perpendicular to come from here till here. Here is the perpendicular's foot going down or going up? Going down. Foot of the perpendicular is going down. Should the phasor particle be to the right or left? Left. Wonderful. This angle will be 45. This angle will be 45. You are asking me the time taken by the foot of the perpendicular to come from here till here. It will be equal to the time taken by the phasor to come from here till here with the constant omega. Yes or no? So time will be pi by 2 by omega. Pi by 2, omega is under root g by r. Pi by 2 under root r. Hence he is HCV. Successfully he converted a problem of gravitation into SHM. He taught us two things. How to draw the phasor also he taught us in this. Till now we always asked you questions on time taken by the particle to go from here till here, t by 4. Here till here, t by 2. Here till here, t. What if I ask you time taken by the particle to come from here till here? Phasor. He asked you the time taken by the particle to come from here till here. Will be as good as the time taken by the foot of the perpendicular to come from here till here. See the directions of the foot of the perpendicular. That means the phasor should come from here till here with a constant omega, which will be the angular frequency of the SHM. So the fifth question of HCV, there are 4 masses this way. There will be force of attraction F1, there will be force of attraction F2, there will be force of attraction F3. all four masses are going about around the same circle. So that means F1, I'll take this cos theta plus F2 cos theta plus F3 should provide the centripetal force m omega square r. This is m, this is m. All four are going about their common center of mass.
So F2 sin theta, right?
Hey, this is theta, this will be theta, this will be the perpendicular bisector. Call this phi then, if you are not convinced. F2 cos phi. Right? F1 cos theta plus F2 cos phi plus F3 should provide the required centripetal force, m omega square r. What was your doubt in this?
Sir, I did that energy conservation also, but I wasn't getting the right answer.
How did you do energy conservation? That's my point. Because I don't
So,
know.
kinetic energy of all four particles is equals to potential energy possessed by these particles.
How do you know that it is not an external force which is making it rotate about the center?
Sir, they haven't stated any of the external forces.
By default, you cannot assume. Energy doesn't work out here.
Okay, sir, thank you.
Let me see if there is any other alternative there with energy. This is straight head. Using energy method, I also never tried this. I'll try and let you know.
Okay, sir. Thank you, sir.
Now listen. This is called a spherical cavity. Spherical cavity. You are cutting out a mass inside a solid sphere. This is the center, this will be O dash. The distance between them is smaller. You cut out a cavity inside a solid sphere. You are interested to know the field inside the cavity. Somewhere here, let this distance be y, let this distance be z. I want the field at the point P. Field at the point P will be field due to complete sphere minus field due to removed part. Field because of the complete sphere here minus field because of the removed part. Field because of the complete sphere at this particular point will be 4 by 3 pi dg z. Field because of the complete sphere here is 4 by 3 pi dg z minus field because of the removed part. Field because of the removed part 4 by 3 pi dgy. Agreed? Field because of the complete sphere here minus the field because of the removed part 4 by 3 pi dg z minus y. This will be the field. What is z minus y equal to? That will be r 4 by 3 pi dgr. Are you trying to tell me field inside the cavity is constant? Yes, it is constant. Field inside the cavity will be constant. Anywhere inside the field it will depend only on the value of small r. Small r is the distance between the two centers. Let us try to correlate this with a thin shell. What did you tell me the field for a thin shell was? Inside, anywhere inside, what will be the field? Louder.
0.
Why it is 0? If this cutout pass was cut out concentrically, what is the value of small r? If I cut this out concentrically, what is the value of small r?
0.
What will be the field?
0.
Hence it is 0. O and O dash are at the same point. Hence the field anywhere inside is
0.
Is the logic clear?
Yes, sir.
If the cutout part would have been concentric, O and O dash will be at the same point. Value of small r will be
0.
value of small r 0 means field anywhere inside will become
0.
wait. The assignment sheet that I have given for SHM, this assignment sheet.
So in the third question, I'm getting the answer is B option, but they've given D.
No, B is right. First question.
I was talking about the third question.
I'll come to third after the first. Third question comes after the first. T by 4, 1 by k equivalent is 1 by 4 whole square by k. Right? And hence the answer. Second question. This is small m. M naught. You have K2, you have K1, energy relation half K1 x square, half K2 x square, half I omega square into 2 cylinders, right, plus half m naught VCM square, half into 2 plus half m V square. VCM is equal to V by 2. Body is rolling. If this is VCM, and this is moving with V, VCM will be V by 2 or V will be 2 times VCM. Remember that. X you are taking is the elongation or compression of the spring. So dx by dt in this problem will be V and VCM will be V by 2.
Sir, doubt is how to do it by torque method?
So you have 5 equations.
See, torque method will be pretty bad because friction about these both and these points also should be taken. Generally, torque method is suggested when you want to take the torque about this point because you will be eliminating torque due to friction. Here if you take the torque about this, torque because of these two frictions will come into picture. That means at least there will be 5 equations. Do not solve using the torque method.
So you're exact
Sir, can you please solve it in the next class? No one in the class has done it.
I don't mind, but how long will you postpone it?
Sir, just one class, sir.
Is that the case with other sections also? Listen, every other section students have completed except ANDHERI kids. Right, I don't mind, I'll postpone it for one more week, but then all other sections that I am taking, Excel, the other batch, section 1, section, even the next section, 4, 5, 6, for them also the discussion is over. You people are the only people for whom it is pending. Keeping you informed just because you need to wake up. Right, from next time don't postpone it so many number of times here. I will also forget to bring these sheets. Right?
Thank you, sir.
Next class for sure get it done. Ask and get it done. If I remember even exercise 4 of the booklet I need to discuss for you people. Please bring that, remind me and get it done.
Sir, please, third wala, can you discuss? Only third question.
Okay. Only third question I will discuss. I will go back to gravitation. Listen, only the third question. This is K, this is M, this is K, this is K, here this is fixed, and this is K, this will be K. If I take this as T, this will be T, this will be T, this will be T and this will be T. Right, this will be 2T. So 1 by K equivalent is equal to 1 square by K plus 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 2 square by K. Hence the answer is B. when you are dealing with Earth, firstly, you said acceleration due to gravity doesn't mean acceleration due to gravity is in this direction, it will be inwards. At this point, acceleration due to gravity is gm by r square. At a height of h, g dash will be gm by r plus h whole square. So g dash by g is r by r plus h whole square. G dash is g into 1 plus h by r to the power minus 2. Agreed? This will be g into 1 minus 2h by r. Remember, this is true only if h is much smaller than r. A famous CET question is like this. They always play with h comparable to r by 4, r by 8, r by 6. Do not use this formula. If I use this formula to give you an idea, when h is r by 2, g dash will become 0. Well, that's not true. R by 2, R by 8, all that you will have to use this formula. This formula is applicable only if h is very small when compared to r. R by 100, R by 200, R by 300, use this. Right? If not, use this particular formula. What if I go, this is to a height, variation of acceleration, variation of g, variation of g. Now come to this, to a depth of h. Suppose I dig a tunnel to a depth of h. I am interested to know the acceleration due to gravity inside. Here, to my convenience, I will change the formula of gm by r square in terms of density, 4 by 3 pi dgr. Because as I am going inside, mass which contributes to g will not remain constant, but density will remain constant. Hence, g dash, this distance is r minus h. 4 by 3 pi dg r minus h. Small r is the distance from the center. G dash by g, r minus h by r. G dash, g into 1 minus h by r. Here there is no approximation. Here there is no approximation. Put h equal to r. G dash will become 0. That means at the center of the earth acceleration due to gravity is 0. Right? Wait.
So in the previous question you did from the worksheet, the question 3, so you use the formula for K equivalent, but isn't that applicable only when the springs are along the same line?
Even if not, see, if you are keeping n number of springs on the same string, all of them are in series. You have kept n number of springs in the same line. They are all in series, except for one spring which is kept above. Satellite is going around the earth. The satellite is going around the earth. What should be the velocity? It is given so that it keeps going around the earth. G capital M small m by r plus h whole square provides the required centripetal force. That will be equal to mv0 square by r plus h. How did you get this? Small m into the field. Field at that point will be G capital M by small r square. Small r is r plus h whole square. Agreed? So V0 will be under root Gm by r plus h. If the satellite is close to the earth's surface, if h is much smaller than r, V0 will be under root Gm by r. If the satellite is close to the earth's surface, V0 will be under root Gm by r. Then what will be its time period? What will be the time period of the satellite? This will be 2 pi r by V0. Why only r? H is very small when compared to r. 2 pi r by, this will be under root Gm by r. Do you recollect? We said GM can be written as GR square. Capital G, capital M mass of Earth will be small g into R square. Right? 2 pi under root 84.6 minutes. If there is a satellite going close to the Earth's surface, time period of the satellite will be 84.6 minutes. That is a very strange theory. I don't know if you people at this age can admire this or not. This is called predeterministic universe. Everything has been decided in advance. How do you prove that? The light coming from the distant stars will reach you tomorrow. But the light started off there few million years back. Few stars are million light years away from us. Few stars are million light years away from us. Light year is the distance travelled by light in 1 year. That means tomorrow's night sky is decided few million years back. Day after tomorrow's night sky is also decided. At least for our lifespan of the next 100 years, assuming, right? The night sky has already been decided few millions of years back. That means the future is already decided. Agreed? Strange but true. If the future was decided million years back, even the past was decided few million years back. No two particles will have the same set of 4 quantum numbers. No two people will be identical. Everybody is unique. One guy's strength may not match with the other guy's strength. One will be strong in intellect, one will be strong in memory, one will be strong in thinking fast, one will be strong in something else. Every one of you are unique. Or I'll put it this way, the predeterministic universe says that generally we look at life always from our perspective. Look at life from the other perspective. The universe is seeing you in this form only once in its lifetime. Universe ka lifetime, your lifetime is 80, 90, 100, 110 years. Universe lifetime is million years. In its lifetime, you in this form will exist only once. In its lifetime, you in this form will exist only once. You will never ever again, or you were never ever in the past existing in this form. In this form means with these eyes, with this nose, with this hairstyle. Everybody's hairstyle will be unique if you people observe. They are dead cells. Yet no two people's hair will be alike. Strange but true. Right? Till date we couldn't design a drop of blood in our labs. We cannot create a single straw of hair which is a dead cell. And yet it is unique. Right? Yet it is unique. That means you in this form, something more strange. You in this form will walk on this globe and live in this universe only once. You understand how precious life is? Not just for you, even for the universe. The universe is also seeing you in this form only once in its lifespan. Give it the opportunity. Right? Now this gives you one more very interesting fact. If the logic is stretched a bit further, genetic engineering says you in this form will be born only to the same set of parents. You can never come into existence to another set of parents. It must be to the same set of parents. You have no choice. That means neither did they have choice, because already future has been decided. You were to be born has been decided. So they didn't have a choice. For your information, take up to your ancestors. Take the geometric progression. From here there will be 2. They didn't have a choice. They had to be married. They were destined to get married. Their parents, grandparents, by the time you scale up by 2 generations, you are speaking about a geometric progression. All the permutations have been decided long back. How many years? Few million years back. Predeterministic universe. Right? So that means even the next generation is also decided. Just chill. Right? Even the next generation is decided. You have no choice in it. Isn't it? Predeterministic universe. For reasons that we don't know, this 84.6 minutes keep following us time and again. Why? We don't know. But it follows. Hence God is great. Look at the greatness In chemistry, you people are taught conservation of angular momentum of an electron in the very first Bohr's atomic model. In gravitation, we will teach you conservation of angular momentum of planets around the sun. That's Kepler's laws. Then we will tell you two stars conserve angular momentum about their common center of mass. We will show that to you. And then we tell you two galaxies conserve their angular momentum about their common center of mass. Whoever created this world, universe, conserved angular momentum for every single atom to every single galaxy. Look at this calculation. Atom is something which your naked eye cannot see. Galaxy is something which your naked eye cannot see. Right from there, minus to plus infinity, he conserved angular momentum with meticulous accuracy of up to 9th decimal place. He didn't go wrong even for a single electron. Nor did he go wrong, he/she, we don't know who. But whoever has done it, awesome job. Much beyond the imagination of all the supercomputers put in the world right now. Put together, we cannot do those calculations. All supercomputers available in the world, put together, we stand nowhere in competition with him in doing that calculation. Hence, God is great. Isn't it? Quick. Geostationary satellite. See, we have a strange problem. You launch a satellite for communication, you need to use it. That means the satellite should be above you. Right? But that is possible only if you are in the equator. Any time the satellite's orbit should be passing through the center of Earth. I can have this as an orbit, I can have this as an orbit. Because G capital M small m by r square should provide the required centripetal force. Pune batch tomorrow, can you come at 1 o'clock?
Yes, sir.
Yes, sir.
1 to 4 tomorrow.
Yes, sir.
Right. Now listen, geostationary satellite is only this. Time period will be 24 hours and geostationary satellite. Any satellite, the path or the orbit should pass through the center of the Earth. That is for sure. I can have a satellite like this. I can have a satellite like this. I can have a satellite like this. I can never have a satellite like this. This will fly off tangentially or it will oscillate about the mean position. If I have Earth this way, I cannot have a satellite like this. It will not stay in equilibrium. It will have a tangential force. Why? If it is here, it will have a force this way. This will have a horizontal and vertical component. So it will be oscillating this way. So the plane of the satellite, orbit of the satellite should be passing through the center of the Earth. But then if you want a geostationary, the satellite should be above you, then you should be on the equator. Only then 24 hours of time period adjusted, you will adjust the height accordingly and it can be geostationary satellite. Stationary with respect to you. Even India is not on the equator, it's slightly above. India comes somewhere here, say. That's the reason why for us, we'll keep going around the Earth this way. We need one satellite like this. By the time our country comes to the other side, we need another satellite like this. If you people ever watch Doordarshan programs, night 9 o'clock there will be a message on the screen. Hereafter the transmission is from inside one way. That means during the morning the transmission is from inside one way. During the night the transmission is from inside one way. You understood how we use the communications. You will not have a stationary satellite always above you unless and until you are on the equator. This is the equator. Nothing to do with the IIT JEE syllabus. Just for your common sense here. Listen. We didn't have our own television network or our own satellite before 1990. I don't know the exact date. when the first transmission satellite was launched, but before 1990 we didn't have television networks. So we were lucky then, no cell phones. All vacations we used to play basketball, volleyball, shuttle, we used to play. Right? That was the best means of enjoyment for us. Before we got independence, we are under the impression that the European country, rather England exploited us. We were exploited to a much greater extent after we got independence, but the only difference is with our consent. How? Listen to this. What did these European countries do? They were on the northern hemisphere. Now for them to have 24 hours communication, they used to launch one satellite this way, one satellite this way, one satellite this way, and one satellite this way, so that all throughout they will have communications. Now look at this. The best part of the joke. What is the fuel used in a satellite? Fuel used in a satellite.
So it doesn't require fuel once it's in operation.
It doesn't require fuel. What fuel is used in moon? It doesn't require fuel. Then why do we need solar panels? For the electronic gadgets on the system to run. Why are you telling us this? That means maintenance cost of a satellite is zero. Maintenance cost of a satellite is. Then why the hell are we paying bills for our cell phones and internet? Because the government decided that way to sell the spectrums with certain frequencies. But for that they can sell it free of cost for us. There is no maintenance. That's why internet is free in US. They are making a fool out of us. 2G spectrum, 3G spectrum, 4G spectrum. Kaika, they are selling wavelengths. Right? And then we are paying bills to Bharti Airtel or any of these Idea Cellulars just to maintain our bill. We are paying bills for the salaries of people who should maintain these bills. That's all. Right? Now, what the European countries then did was, they had this satellite launch. They can use this satellite only for this part of the journey. By then their country will go to the other side. So the remaining part of the journey for their satellite is a waste for them. They sold it for developing countries at very high cost. How high can you make an estimate? I will give you one example, you make an estimation on that. 1987, I called up my cousin from Visakhapatnam, called up my cousin in Hyderabad. Then Visakhapatnam and Hyderabad were in the same state. 12 hours of a journey. Night 9 o'clock. Why? Only night 9 o'clock the satellite is available for us. The cost will go down to 1/4. At 1/4 the rate, I called him up to tell him that look, within Hyderabad all the numbers, koi disconnect ho gaya yaar. Within Hyderabad all the numbers are connected by cables. Right? For them it was 1 rupee call, local call. I had to call him up, tell him that look, from Central University I didn't receive the hall ticket. The information brochure, Central University's phone number is this. My hall ticket number is this. I didn't receive my registration number is this. I didn't receive my hall ticket. Kindly call up tomorrow Central University, tell me what is the status. Whole of this information I gave him in 1 minute. I put down the phone and I paid 47 rupees. 1987 mein 47 rupees means it's a huge amount. Where did all this money go? We were buying slots from the other satellites. So they sold. If one person after night 9 o'clock at 1/4 the rate is paying 47 rupees for communication within the state, all over the country, just imagine how much we might be paying. All that went into the coffers of the developed countries. Then we realized we need to have a satellite of our own, only then the communications will come down. Now you know how cheap the communications are. 50 paise. 1 paise per second. Right? Why? Because they can give you even free of cost. They don't give it because there should be some evaluation for the system. You are selling wavelengths. That's why FM 91.1 in communication chapter I will tell you all FM frequencies will be between 90 to 108. That's why all FM radios are within the same wavelength. They'll give you the ranges. Right? Communication satellites, main purpose is this. If you people have seen this movie, Independence Day, the theme of the movie was There is a foreign satellite which has taken all the other satellites into control, but it can cover only this range. So it has taken a Russian satellite and an American satellite into its control. This guy, when he runs into the presidential palace, he explains the president, after so many minutes, that particular foreign body will be exactly above White House. The second information he gives is, after so many hours, so many minutes, so many seconds, these three will be in an equilateral triangle form. And these two, one the US and the other the Russian satellite, are equipped with nuclear arsenal. If all three fire simultaneously, the globe is covered. Hence the theme of the movie was, before this satellite comes into that particular position, within so many hours, so many minutes, so many seconds, you are supposed to destroy this. They try to make an attempt, it fails. Then the two heroes of the movie enter inside and install virus into the system, and hence you can destroy it. Right? Till 3-4 years back, Star TV network, they used to give us, for any program, UAE timing and Bangladesh timing. UAE to Bangladesh, they had the coverage. It is after they digitalized, every country gets its respective time of that particular program. Right? Now I believe even America has got star networks because they are buying slots from the other side. The other side of the globe used to not previously get star network. Now they are getting because they have purchased a slot from the other satellite there. Satellites once sent cannot be bought back. They will be few thousand kilometers above. Why do you want to launch another satellite? Because the electronic components of the satellite will get outdated. What was our first satellite? Aryabhatta. The supercomputer on our first satellite, its maximum capacity was approximately 2 GB. Supercomputer. Now your 2 GB will be something very small for you people. Right? Fine. Hence, now it has been outdated. You cannot send an engineer to upgrade it. So relaunch a new satellite with the new communication systems.
Isn't that dangerous?
What will you do with the satellite there? Unless and until it is equipped with nuclear arsenal, no satellite is dangerous.
But so what is there too many satellites orbiting around?
They are like merry-go-round. They can go with constant angular velocity. In the same orbit, I can have innumerable number. I can have any number of satellites in the same orbit. Unless and until one explodes, I don't have a problem with it. Right? So don't equip your satellites with nuclear arsenal, which actually was done during Cold War by US. 2010 or 11, they hit one satellite because there was news of some radioactive traces in the atmosphere which were leaking from the satellite. So from one of their naval ships, a well-planned, calculated hit on that satellite to push it out of Earth's orbit, which they were successful, if I am right. Though much of that information is classified, whatever the press released was minimal on that. Fine.